Oh, how are you all? How are you, dear friends? Today we are going to talk about hypothesis test for standard deviation. So here I go. The standard deviation of the annual temperature of a city over a period of 100 years was 16 degree Fahrenheit. Using the mean temperature on the 15th day of each month during the last 15 years, a standard deviation of annual temperatures was computed as 10 degree F. Test the hypothesis that the temperatures in the city have become less variable than in the past using the significance levels of part A 0.05 and B 0.01. So two different significance levels. So first we have to write the null hypothesis. So if I can move this a little bit. So see if I can move this. Oops. Let's move this a little bit. Okay. So let's go back to here. So in the past, for 100 years, the standard deviation of the temperature and the annual temperature of the city was 16 degree Fahrenheit. So a null hypothesis, H sub 0, is sigma equal to population standard deviation equal to 16. Okay, so that's the null hypothesis. Now it says test the hypothesis that the temperature in the city have become less variable than in the past using two different significance levels. So basically become less variable. That means our alternate hypothesis H sub A is sigma. Less variable means less than 16. So less than means these two slanted lines indicating less than pointing to the left is a left-tailed test. Left-tailed test means area of rejection will fall in rejection of H0 will fall in the left tail of chi-square distribution. Okay. So first we have to calculate a test statistic. Okay. So what is a test statistic? It's a characteristic of the sample which we have gathered. So calculate a test statistic, which is a characteristic of the sample, which is a characteristic of the sample that we have gathered. Remember, we have looked at the temperature on the 15th of each month for the last 10 years of the sample we have gathered. So basically, the sample is the temperature on the 15th of each month for the last 10 years, whereas the population standard deviation comes from 100 years of data. Okay. The test statistic here is chi-square. This is chi-square. Although written as chi square, it is not chi, it is chi-square. Okay. And the formula for that in this case is n minus 1 times s square divided by sigma 0 square. So let me explain what do each of these terms means. So N is your sample size, okay, which is equal to last 10 years, N equal to 10. S is the sample standard deviation, which if I lower, you will see this, oops, the sample standard deviation was 10 degree Fahrenheit, okay? So S is 10 degree Fahrenheit from the last 10 years, 15th of each month for the last 10 years, S is 10, okay? And what is the sigma 0? Is the value hypothesized or guessed in the null hypothesis. In the null hypothesis. So sigma 0 in this case is equal to 16. Okay, so we are all set to calculate the test statistic chi-square. So chi-square will be equal to n is 10 minus 1 times sample standard deviation is 10 square divided by sigma 0 is 16 square, which is 9 multiplied by 10 divided by 16 squared. So we will use my calculator TI-84. So I will do a left parenthesis first. Left parenthesis, inside the left parenthesis 10 divided by 16. Then the right parenthesis, then I'll square this thing. So 10 divided by 16 inside the left and right parenthesis, then square by pressing the x square button, then multiply the whole thing by 9. And that will work out to 3.5156. So remember, this is a left tilt test. So because it's less than. So let me move this a little bit up. So basically, if I draw the chi-square distribution, this is your chi-square distribution. For degrees of freedom, df is equal to n minus 1 is 10 minus 1 is 9. So our test statistic is, so this is 0. Our test statistic is somewhere over here. 3.5156. And remember, this is a left tail test, so this is the p-value. Calculate a p-value, which is the area to the left of the test statistic. Under the chi-square curve, under the chi-square distribution. For df is equal to 9. Okay, so how will I do that? Use TI-84. Okay, so in our calculator, we'll first press the stat button, then we will go to test. No, wrong. TI-84, we press the second key first, then verse key. And then scroll down to chi-square CDF. This is scroll down. Scroll down. So second worse, and then scroll down to chi-square CDF. Okay, and hit enter once you see chi-square CDF. So it asks for a lower value. Is the lower boundary, lower is 0. Upper is where I will stop, is 3.5156. And degrees of freedom is 10 minus 1 is 9. And we will put the cursor on paste and hit enter and enter. So p-value area to the left of 3.5156 is equal to, so my lower is 0 because I'm starting from my 0 on the left, and my upper boundary is 3.5156, and my degrees of freedom is 9. And I go down to paste, hit enter and enter. And this is 0.05. Okay, that's your p-value. So if alpha is equal to 0.05 level of significance, remember, level of significance is the maximum probability of rejecting H0 when it is true. So alpha is max probability of rejecting H0. Oops. Probability of rejecting H0, of rejecting H0 when it is true. Okay. So compare p-value with alpha is equal to 0.05. Oops. So with alpha equal to 0.05. So P is equal to 0.059. Alpha is 0.05. P is greater, P value is greater than alpha. Decision: do not or fail to reject H0. And the conclusion is at alpha is equal to 0.05, there is not enough evidence to support H1. Evidence to support H1 or HN, which is sigma less than 16. Okay, so that is part A. Okay, so this is part A. Okay, and then we will move this a little bit up. And then our part B, alpha is 0.01. Our p-value does not change. P is still equal to 0.059. Again, P is greater than alpha. Same decision. Fail to reject H0. Fail to reject H0. And we also write the conclusion at alpha is equal to 0.05. There is not enough evidence. Same conclusion as before to support not 0.05, my mistake. This is 0.01 now to support HA sigma less than 16. Okay, so we are not supporting, it's not. Okay, and the decision is, I will highlight, in both the cases it is failed to reject H0. Same over here, failed to. And in both cases the p-value is greater than alpha value. That's why we failed to reject H0. Okay, so I'll summarize. Let me summarize quickly what's going on. So first we formulated the problem. Okay, so it's a test whether it's less variable than what is that it has been in the past for 100 years. That means HA is sigma less than 16. Null hypothesis is sigma equal to 16. Okay, so we have to calculate a test statistic based on our sample data. Remember, test statistic is a characteristic of the sample. In this case, the test statistic is chi-square, which is given by this formula. We calculate that chi-square test statistic value of 3.5156. Because this is a left tail test, because of less than in the alternate, we find the area to the left of the test statistic under the chi-square distribution for degrees of freedom equal to 9. For that, we use our TI-84 calculator, and we find the area or the p-value equal to 0.059. Then we compare that p-value to the alpha value of 0.05. In both the cases, alpha is 0.05 and alpha equal to 0.01. P-value is greater than alpha. Decision is failed to reject H0, and therefore there is not enough evidence to support the alternate hypothesis in both cases, which is sigma less than 16. So I stop here today. Please write me a note. Please write me a comment. I really appreciate that. And if you like this video, please give me a thumbs up. That motivates me to produce more videos which are useful to you. And if you do not like this video, please give me a thumbs down. See, I make a lot of videos. Some are good, some are not so good. So if you think the quality is not that great, give me thumbs down. I will learn from my mistake and improve on the quality. Okay. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to let YouTube know that you'd like to be notified every time I upload a new video, which I do one video per day almost. Okay. So please stop by tomorrow and check out a new video. Thanks for watching. Thanks for doing all you do. I really appreciate that. Okay. If you want me to solve any particular problem, let me know. Okay. Take care. Have a nice day. See you next time.